In problem 2 on the CAT review, notice that we have a problem that has an applied force with two cables, right? And so we ultimately have a concurrent force system. If we come and take a cut around that joint at A, of course you'd get a force of 20 kips acting down. You've got the cable force B, and you got the cable force C. And you could do sum of forces in the x and y if you wanted to, or recognizing that you have a three-force system that is a concurrent force system, then what you could also do is look at this in terms of laying this out. If you want to do tip to tail, you could do that. You've got B, unknown distance, C, a hypotenuse, unknown magnitude, and then you've got the actual applied force. We know that one at 20. And although we don't know yet the angles here, you can calculate them if you wanted to, or recognize that you got a 715 triangle going on here, and when you go look at what that other side is going to be, of course that'd be 225, that's 15 squared, minus the 7 squared, or 49, take the square root, and we get 13.266 for that final side. And so that means the proportions here of that geometry have to be the same as the proportions of a congruent triangle as the force magnitudes that we have that we're being requested to find. And so C is to 20 the same way as 15 is to 7, so therefore C would of course then equal 20 times 15 divided by 7, or 42.85 kips. Notice how large that gets. That inclined force to pick up that 20 kip vertical component has to become quite large. And then B is to 20 as then 13.266 is to 7. And so now we get that B is going to be equal to 37.9 kips.